Hello viewers, now today's lecture in physics we are going to be looking at vector. First, let's define a vector quantity. Now a vector quantity is a quantity that has both magnitude and direction. So a vector quantity shows the magnitude or the numerical value or the size of the vector as well as the direction. Examples include displacement, velocity, acceleration, force, momentum, etc. Unlike scalar quantities, which has only magnitude but no direction, vector quantities have both magnitude and direction. Say for instance, a boy walks 5 meters due east. This quantity being represented now is a vector quantity because 5 meters here represents the magnitude, while due east shows the direction through which the boy walked. So this is actually displacement, which is a vector quantity showing both the magnitude and the direction. Then going over to vector representation. Now vectors can be represented using lines with arrowhead. Using lines with arrowhead like this illustrated here. Now the length of the line represents the magnitude of the vector, while the arrowhead points towards the direction of the vector. The length represents the magnitude of the vector or size of the vector, while the arrowhead points towards the direction of the vector. Then, moving over to resultant vector. A resultant vector is that single vector that we have the same effect in magnitude and direction as the other vectors acting together. What do we mean by that? Let's take for instance, we have an object being pulled to the right by a force of 15 Newton and it's also pulled to the left by a force of 10 Newton. Of course, we know that this object will move towards the right because the force acting on it by the left hand side is higher. So the net force is going to be 15 Newton to the right. So this net force acting on these objects is what we call the resultant force. Now let's say we want to replace these two vectors or these two forces with a single force. We want to replace these two forces with a single force that will also give me this same 5 Newton and also move the object to the right direction. That force that will move these objects with the same magnitude of 5 Newton and to the right is what we call the resultant force, or in this case the resultant vector, and which is simply this. So these two illustrations are similar, they are the same because they imply the same thing. The net force acting on this is 5 Newton to the right, and the resultant or the net force acting here is also 5 Newton to the right. Now look at another illustration. Now these two forces, 15 Newton and 10 Newton, they are acting in the same direction. They are pulling it both of them are pulling the objects to the right. So which means the net force here, or the resultant force, is equal to 15 plus 10, which is what? 25 Newton. So, which is 25 Newton. So that single force that can replace these two vectors is what? 25 Newton. And will also give me the same effect in magnitude and direction as the other forces acting together, or the other vectors acting together. So that is the resultant vector. That vector that will have the same effect in magnitude and in direction as the other vectors acting together. They can be used to replace two or more vectors acting together. That single force or the single vector is what we call the resultant vector. Now, what if we have two vectors that are inclined at an angle to each other? If we have two vectors that are inclined at an angle to each other, of course we can't just do mere addition and mere subtraction in this case. We use what we call the parallelograms law of vector. And now from the parallelograms law of vector, we have that the adjacent sides of a parallelogram represent So if we have two vectors inclined at an angle, let's call it theta, we can use the parallelograms law to represent the vectors and to also calculate the resultant vector. All we just need to do is to complete the parallelogram. Now, parallelograms law tells us that the adjacent sides of the parallelogram represents the magnitude of the two vectors. The adjacent sides of the parallelogram represents the magnitude of the two vectors, while the diagonal passing through the point of intersection between the two vectors represents the resultant vector. Now all I've been saying now is that if we have, let's say we have vector q, and then we have another vector here, vector p, and both of them are inclined at an angle, let's say theta. Now from parallelograms law, all we need to do is to complete this parallelogram. Okay, of course here is also q and here is p. Now these two adjacent sides of the parallelogram represent the magnitude of the two vectors, which are p and q, while the diagonal passing through this point here represents the resultant of the parallelogram, or sorry, represent the resultant of these two vectors p and q. So here is the angle of inclination, and now if here is theta, then the angle facing the resultant, which is this place, is going to be 180 minus theta. So the formula which we use from parallelograms law to find the resultant of two vectors which are inclined at an angle is r squared equals p squared plus q squared minus 2pq cos 180 minus theta. Then let's go over to this question. It says that two vectors of magnitude 5 Newton and 7 Newton are inclined at an angle of 30 degrees to each other. So let's say this is the force of 7 Newton and this is that of 5 Newton, and they are inclined at an angle of 30 degrees. So to complete the parallelogram, we have this. Okay, and of course here is going to be 30 degree, and if here is 30 degree, then definitely here is going to be 180 minus 30, which is 150. So from the formula we have r squared equals p squared plus q squared minus 2pq cos 180 minus theta. So r squared, let's take our p as 5, so our 5 squared, take our q as 7 squared minus 2 times 5 times 7, then cos 180 minus 30. So this becomes r squared equals 5 squared is 25, 7 squared is 49, then 2 times 5 times 7 is 70, cos 180 minus 30 is 150. So that r squared equal to, now don't make the mistake of doing 25 plus 49 minus 70. No, that is a very big error. Instead, just add these two first, 25 plus 49 to give us 74 minus 70 cos 150. So r squared equals 74 minus 70 cos 150 from our calculator is going to give us minus 6.062. So r squared is equal to 74 minus times minus is plus, so I have point. Okay, So we have r square equals this plus this is going to give us 80.062. Now finally we find the square root, and therefore our resultant is equal to 8.95 Newton. So this is how we calculate the resultant. Now we just calculated the magnitude of the resultant vector, or resultant force in this case. We also need to calculate the direction of the resultant vector. A vector has both magnitude and direction. I've just concluded in calculating the magnitude of the vector. Now let's go over to the direction of the vector. Now to calculate the direction of the vector, we use what we call Lami's theorem, or what is popularly known as the sine rule. So which says that if we go back to this, to apply sine rule here, we have that the side facing this angle here is r over the angle we have here, which is sine, okay, let's call it sine alpha for instance. Let's say the angle here is alpha, so the side facing alpha is r over sine alpha, equal to, look at this angle, let's call this angle here angle P, and let's call this angle here angle Q. So the side facing angle P is P, so I have P over sine angle P, which is also equal to Q over sine angle Q. So let's see how we're going to apply it here. So we have that the resultant is this is the resultant r. So if I break this parallelogram apart, we'll have an obtuse triangle like this, something looking like this, and here is 150 degree, here is 7 Newton, 5 Newton, and here is the resultant, which is 8.95 Newton. So from the sine rule of Lami's theory, we have that r, which is 8.95 over sine 150, equal to, now this is where the direction of the resultant is. So I'm going to call it alpha. So we have 8.95 Newton over sine 150 equal to, we have over sine alpha. Now this alpha is facing a side of 5 Newton, so I have 5 over here. I know this might be a little bit confusing. Now let me go again. The resultant, the angle facing the resultant is 150 degrees, so I have sine 150, then the side, which is 8.95, equal to the side facing this sine alpha, which is the direction, is 5 Newton, so I have 5 over sine alpha. So cross multiplying, we'll have that 8.95 times sine alpha equals 5 sine 150. Then if we divide both sides by 8.95, so this cancels out to have sine alpha equals 5 sine 150 over 8.95. So we have that sine alpha equals, from our calculator, if we multiply and divide everything, we have 0.27 16.93. Then to finally look for the direction, which is alpha, we have that alpha equals sine inverse of 0.2793, which will definitely give us 16.22 degree. So the resultant of these two vectors is 8.95 Newton in the direction of 16.22 degree. I think this is where we're going to end it. Thank you very much for watching. And remember to click the subscribe button. Thanks.